In class 9th, we have studied classification of given data into ungrouped as well as grouped frequency distributions, representation of the data pictorially in the form of various graphs such as bar graphs, histograms, and frequency polygons, numerical representatives of the ungrouped data, that is, measures of central tendency, namely mean, median, and mode. If x1, x2 up to xn observations with respective frequencies f1, f2 up to fn, then x1 occurs f1 times, x2 occurs f2 times, and so on. Now, the sum of the values of all the observations is equal to f1x1 plus f2x2 plus up to fnxn, and the number of observations is equal to f1 plus f2 plus up to fn. So, the mean x of the data is given by x bar equal to f1 x1 plus f2 x2 plus up to fnxn upon f1 plus f2 plus up to fn. In short form, it can be written as x bar is equal to summation of I equal to 1 upon n fi xi upon summation of 1 equal to 1 upon n fi. Example 2. The distribution below shows the number of wickets taken by bowlers in one-day cricket matches. Find the mean number of wickets by choosing a suitable method. What does the mean signify? Number of wickets, number of bowlers. 20 to 60, 7. 60 to 100, 5. 100 to 150, 16. 150 to 250, 12. 250 to 350, 2. 350 to 450, 3. Solution. Here, the class size varies and the xi's are large. Let us still apply the step deviation method with A equal to 200 and H equal to 20. Then we obtain the data as in table: number of wickets taken, number of bowlers fi, xi, di equal to xi minus 200, ui equal to di upon 20, ui fi. 20 to 60, 7. 40, minus 60, minus 8, minus 56. 60 to 100, 5. 80, minus 120, minus 6, minus 30. 100 to 150, 16. 125, minus 75, minus 3.75, minus 60. 150 to 250, 12. 200, 0, 0, 0. 250 to 350, 2, 300, 100, 5, 10. 350 to 450, 3, 400, 200, 10, 30. Total 45, minus 106. So, u bar is equal to minus 106 upon 45. Therefore, x bar is equal to 200 plus 20 into minus 106 upon 45, equal to 200 minus 47.11 equal to 152.89. This tells us that, on an average, the number of wickets taken by these 45 bowlers in one-day cricket is 152.89. Let us apply this formula to find the mean in the following example. The marks obtained by 30 students of class 10 of a certain school in a mathematics paper consisting of 100 marks are presented in the table below. Find the mean of the marks obtained by the students. Marks obtained xi 10, 20, 36, 40, 50, 56, 60, 70, 72, 80, 88, 92, 95. Number of student Fi 1, 1, 3, 4, 3, 2, 4, 4, 1, 1, 2, 3, 1. Solution. Recall that to find the mean marks, we require the product of each xi with a corresponding frequency Fi. So, let us put them in a column as shown in table. Marks obtained, number of students, Fi, xi. 10, 1, 10. 20, 1, 20. 36, 3, 108. 44, 160. 53, 150. 56, 2, 112. 64, 240. 74, 280. 72, 1, 72. 80, 1, 80. 88, 2, 176. 92, 3, 276. 95, 1, 95. Total sigma Fi is equal to 30. Sigma Fi xi is equal to 1779. X bar is equal to sigma Fi xi upon sigma Fi equal to 1779 upon 30 equal to 59.3. Class interval, number of students, 10 to 25, 2, 25 to 40, 3, 40 to 45, 7, 55 to 70, 6, 70 to 85, 6, 85 to 100, 6. It is assumed that the frequency of each class interval is centered around its midpoint. So the midpoint or class mark of each class can be chosen to represent the observations falling in the class. Class mark is equal to upper class limit plus lower class limit upon 2. With reference to table for the class 10 to 25, the class mark is 10 plus 25 upon 2 equal to 17.5. Similarly, we can find the class marks of the remaining class intervals. We put them in another table. Class interval, number of students, Fi, class mark, xi, Fi, xi. 10 to 25, 2, 17.5, 35. 25 to 40, 3, 32.5, 97.5. 40 to 55, 7, 47.5, 332.5. 55 to 70, 6, 62.5, 375. 70 to 85, 6, 77.5, 465. 85 to 100, 6, 92.5, 555. Total, sigma Fi is equal to 30. Sigma Fi xi is equal to 1860. The sum of the values in the last column gives us sigma Fi xi. So the mean x of the given data is given by x bar is equal to sigma Fi xi upon sigma Fi equal to 1860 upon 30 equal to 62. This new method of finding the mean is known as the direct method. Step 1. Choose one among the xi as the assumed mean and denoted by A. We may take A to be that xi which lies in the center of x1, x2 up to xn. So we can choose A equal to 47.5 or A equal to 62.5. Let A be equal to 47.5. Step 2. Find the mean D between A and each of the xi's, that is, the deviation of A from each of the xi's. That is, Di is equal to xi minus A equal to xi minus 47.5. Step 3. Find the product di with the corresponding fi and take the sum of all the fi's di's. The calculations are shown in Table 3. Class interval, number of students fi, class mark, xi, di equal to xi minus 47.5, fi di. 10 to 25, 2, 17.5, minus 30, minus 60. 25 to 40, 3, 32.5, minus 15, minus 45. 40 to 55, 7, 47.5, 0, 0. 55 to 70, 6, 62.5, 15, 90. 70 to 85, 6, 77.5, 30, 180. 85 to 100, 6, 92.5, 45 to 70. Total sigma fi is equal to 30, sigma fi di is equal to 435. From Table 3, the mean of the deviations d bar is equal to sigma fi di upon sigma fi. Mean of the deviations d bar is equal to sigma fi di upon sigma fi. D bar is equal to sigma fi into xi minus a upon sigma fi equal to sigma fi xi upon sigma fi minus sigma fi a upon sigma fi equal to x bar minus a into sigma fi upon sigma fi equal to x bar minus a, x bar equal to a minus d bar, x bar equal to a plus sigma fi di upon sigma fi. Substituting the values of a, sigma fi di and sigma fi from Table 3, we get x bar is equal to 47.5 plus 435 upon 30 equal to 47.5 plus 14.5 equal to 62. Therefore, the mean of the marks obtained by the students is 62. The method discussed above is called the assumed mean method. From the Table 2, by finding the mean by taking each of xi, that is 17.5, 32.5 and so on as a, we will find that the mean determined in each case is the same, that is 62. In Table 3, the values in column 4 are all multiples of 15. So, if we divide the values in the entire column 4 by 15, we would get smaller numbers to multiply with fi. Here, 15 is the class size of each class interval. Let ui be equal to xi minus a upon h, where a is the assumed mean and h is the class size. Now, we calculate ui in this way and continue as before, that is find fiui and then sigma fiui. Taking h equal to 15, let us form Table 4. Class interval fi, xi, di equal to xi minus a, ui equal to xi minus a upon h, fiui 10 to 25, 2, 17.5, minus 30, minus 2, minus 4. 25 to 40, 3, 32.5, minus 15, minus 1, minus 3. 40 to 55, 7, 47.5, 0, 0, 0. 55 to 70, 6, 62.5, 15, 1, 6. 70 to 85, 6, 77.5, 30, 2, 12. 85 to 100, 6, 92.5, 45, 3, 18. Total sigma fi equal to 30, sigma fiui equal to 29. Relation between u bar and x bar. Let u bar be equal to sigma fiui upon sigma fi. ui equal to xi minus a upon h. U bar equal to sigma fi into xi minus a upon h upon sigma fi equal to 1 by h into sigma fi xi minus a sigma fi upon sigma fi equal to 1 by h into sigma fi xi upon sigma fi minus a sigma fi upon sigma fi equal to 1 upon h into x bar minus a. H u bar equal to x bar minus a, x bar equal to a plus h u bar, x bar equal to a plus h into sigma fi ui upon sigma fi. Now, substituting the values of a, h, sigma fi ui and sigma fi from table 4, we get x bar equal to 47.5 plus 15 into 29 upon 30 equal to 47.5 plus 14.5 equal to 62. So the mean marks obtained by a student is 62. The method discussed is called the step deviation method. Let's solve some examples using these methods. Example 1. The table below gives the percentage distribution of female teachers in the primary schools of rural areas of various states and union territories of India. Find the mean percentage of female teachers by all the three methods discussed in this session. Percentage of female teachers and number of states or UT. 15 to 25, 6. 25 to 35, 11. 35 to 45, 7. 45 to 55, 4. 55 to 65, 4. 65 to 75, 2. 75 to 85, 1. Solution. Let us find the class marks X of each class and put them in a column. Percentage of female teachers, number of states UTFI, XI. 15 to 25, 6, 20. 25 to 35, 11, 30. 35 to 45, 7, 40. 45 to 55, 4, 50. 55 to 65, 4, 60. 65 to 75, 2, 70. 75 to 85, 1, 80. Here we take A equal to 50, H equal to 10, then DI is equal to XI minus 50 and UI is equal to XI minus 50 upon 10. We now find DI and UI and put them in table shown. Percentage of female teachers, number of states UT FI, XI, DI equal to XI minus 50, UI equal to XI minus 50 upon 10, FIXI, FIDI, FIUI. 15 to 25, 6, 20, minus 30, minus 3, 120, minus 80, minus 18. 25 to 35, 11, 30, minus 20, minus 2, 330, minus 220, minus 22. 35 to 45, 7, 40, minus 10, minus 1, 280, minus 70, minus 7. 45 to 55, 4, 50, 0, 0, 200, 0, 0. 55 to 65, 4, 60, 10, 1, 240, 40, 4. 65 to 75, 2, 70, 20, 2, 140, 40, 4. 75 to 85, 1, 80, 30, 3, 80, 30, 3. Total 35, 1390 minus 360 minus 36. From the table above, we obtain sigma Fi equal to 35, sigma Fi Xi equal to 1390, sigma Fi Di equal to minus 360, sigma Fi Ui equal to minus 36. Using the direct method, x bar is equal to sigma Fi Xi upon sigma Fi equal to 1390 upon 35 equal to 39.71. x bar is equal to a plus sigma fi di upon sigma fi equal to 50 plus minus 360 upon 35 equal to 39.71. Using the step deviation method, x is equal to x bar equal to a plus sigma fi ui upon sigma fi into h equal to 50 plus minus 36 upon 35 into 10 equal to 39.71. Therefore, the mean percentage of female teachers in the primary schools for rural areas is 39.71. Remark: the result obtained by all the three methods is the same. So the choice of method to be used depends on the numerical values of xi and fi. If xi and fi are sufficiently small, then the direct method is an appropriate choice. If xi and fi are numerically large numbers, then we can go for the assumed mean method or step deviation method. If the class sizes are unequal and xi are large numerically, we can still apply the step deviation method by taking h to be a suitable divisor of all the di's. We know that a mode is that value among the observations which occurs most often. Mode is the value of the observation having the maximum frequency. We shall discuss ways of obtaining a mode of grouped data. When more than one value may have the same maximum, then data is said to be multimodal. Though grouped data can also be multimodal, we shall restrict ourselves to problems having a single mode only. The wickets taken by a bowler in 10 cricket matches are as follows: 2, 6, 4, 5, 0, 2, 1, 3, 2, 3. Find the mode of the data. Solution: let us form the frequency distribution table of the given data as follows. Number of wickets, number of matches. 0, 1, 1, 1, 2, 3, 3, 2, 4, 1, 5, 1, 6, 1. Clearly, 2 is the number of wickets taken by the bowler in the maximum number, that is 3, of matches. So the mode of this data is 2. In a grouped frequency distribution, it is not possible to determine the mode by looking at the frequencies. Here, we can only locate a class with the maximum frequency called the modal class. The modal is a value inside the modal class and is given by the formula mode equal to L plus F1 minus F0 upon 2F1 minus F0 minus F2 into H, where L is equal to lower limit of the modal class, H is equal to size of the class interval. Assuming all class sizes to be equal, F1 is equal to frequency of the modal class, F0 equal to frequency of the class preceding the modal class, and F2 equal to frequency of the class succeeding the modal class. Median is a measure of central tendency which gives the value of the middlemost observation in the data. For finding the median of ungrouped data, first arrange the data values of the observations in ascending order. If n is odd, the median is the n plus 1 upon 2th observation. If n is even, then the median will be the average of the n upon 2th and the n upon 2 plus 1 observations. Find the median of the following data, which gives the marks out of 50 obtained by 100 students in a test. Marks obtained: number of students 26, 29, 28, 28, 24, 33, 15, 42, 2, 38, 4, 43, 1, 25, 20. First, we arrange the marks in ascending order and prepare a frequency table as follows. Marks obtained, number of students, frequency 26, 25, 20, 28, 24, 29, 28, 33, 15, 38, 4, 42, 2, 43, 1. Total 100. Here, n is equal to 100, which is even. The median will be the average of the n upon tooth and the n plus 1 upon tooth observation, that is, the 50th and the 51st observations. To find these observations, we proceed as follows. Marks obtained, number of students. 26. Up to 25, 6 plus 20 equal to 26. Up to 28, 24 plus 26 equal to 50. Up to 29, 50 plus 28 equal to 78. Up to 33, 78 plus 15 equal to 93. Up to 38, 93 plus 4 equal to 97. Up to 42, 97 plus 2 equal to 99. Up to 43, 99 plus 1 equal to 100. Now, we add another column depicting this information to the frequency table above and name it as Cumulative Frequency column. Marks obtained, number of students, cumulative frequency. 26, 6. 25, 20, 26. 28, 24, 50. 29, 28, 78. 33, 15, 93. 38, 4, 97. 42, 2, 99. 43, 1, 100. From the table above, we see that 50th observation is 28, 51st observation is 29. So, median is equal to 28 plus 29 upon 2 equal to 28.5. Column 1 and column 3 is known as cumulative frequency table. The median marks 28.5 conveys the information that about 50% of the students obtained marks less than 28.5 and another 50% students obtained marks more than 28.5. A grouped frequency distribution of marks obtained out of 100 by 53 students in a certain examination as follows. Marks, number of students. 0 to 10, 5. 10 to 20, 3. 20 to 30, 4. 30 to 40, 3. 40 to 50, 3. 50 to 60, 4. 60 to 70, 7. 70 to 80, 9. 80 to 90, 7. 90 to 100, 8. From the table, we can observe students have scored marks less than 10 is 5. Students have scored less than 20 marks. The total number of students with marks less than 20 is 5 plus 3, that is 8. We say that the cumulative frequency of the class 10 to 20 is 8. Number of students with marks less than 30, less than 40, up to less than 100. This can be done by computing the cumulative frequencies shown in form of table. Marks obtained, number of students, cumulative frequency. Less than 10, 5. Less than 20, 5 plus 3, 8. Less than 30, 8 plus 4, 12. Less than 40, 12 plus 3, 15. Less than 50, 15 plus 3, 18. Less than 60, 18 plus 4, 22. Less than 70, 22 plus 7, 29. Less than 80, 29 plus 9 equal to 38. Less than 90, 38 plus 7, 45. Less than 100, 45 plus 8, 53. The distribution given above is called the cumulative frequency distribution of the less than type. Here, 10, 20, 30 up to 100 are the upper limits of the respective class intervals. Number of students with scores more than or equal to 0, more than or equal to 10, more than or equal to 20, etc. From given table, we observe that all 53 students have scored marks more than or equal to 0. Since there are 5 students scoring marks in the interval 0 to 10, this means that there are 53 minus 5 equal to 48 students getting more than or equal to 10 marks. Continuing in the same manner, we get the number of students scoring 20 or above as 48 minus 3 equal to 45, 30 or above as 45 minus 4 equal to 41, and so on as shown in table. Marks obtained, number of students, cumulative frequency, more than or equal to 0, 53. More than or equal to 10, 53 minus 5 equal to 48. More than or equal to 20, 48 minus 3 equal to 45. More than or equal to 30, 45 minus 4 equal to 41. More than or equal to 40, 41 minus 3 equal to 38. More than or equal to 50, 38 minus 3 equal to 35. More than or equal to 60, 35 minus 4 equal to 31. More than or equal to 70, 31 minus 7 equal to 24. More than or equal to 80, 24 minus 9 equal to 15. More than or equal to 90, 15 minus 7 equal to 8. The table above is called a cumulative frequency distribution of the more than type. Here, 0, 10, 20 up to 90 give the lower limits of the respective class intervals. Now to find the median of grouped data, we can make use of any of these cumulative frequency distributions. Let us combine the previous tables to get new table given below. Marks, number of students, F, cumulative frequency, CF. 0 to 10, 5, 5. 10 to 20, 3, 8. 20 to 30, 4, 12. 30 to 40, 3, 15. 40 to 50, 3, 18. 50 to 60, 4, 22. 60 to 70, 7, 29. 70 to 80, 9, 38. 80 to 90, 7, 45. 90 to 100, 8, 53. In a group data, it is not able to find the middle observation by looking at the cumulative frequencies, as the middle observation will be some value in a class interval. It is therefore necessary to find the value inside a class that divides the whole distribution into two halves. To find this class, find the cumulative frequencies of all the classes and n upon 2. Locate the class whose cumulative frequency is greater than and nearest to n by 2, that is 26.5. This is called the median class. In the distribution above, n is equal to 53, so n by 2 is equal to 26.5. Now, 60 to 70 is the class whose cumulative frequency 29 is greater than and nearest to n by 2, that is 26.5. Therefore, 60 to 70 is the median class. After we can calculate the median class by following formula, median is equal to L plus n by 2 minus CF upon F into H, where L is equal to lower limit of median class, n is equal to number of observations, CF is equal to cumulative frequency of class preceding the median class, F is equal to frequency of median class, H is equal to class size, assuming class size to be equal. Substituting the values n by 2 equal to 26.5, L equal to 60, CF is equal to 22, F equal to 7, H equal to 10. In the above formula, we get a survey regarding the heights in centimeter of 51 girls of class 10 of a school was conducted and the following data was obtained. Height in centimeter, number of girls. Less than 140, 4. Less than 145, 11. Less than 150, 29. Less than 155, 40. Less than 160, 46. Less than 165, 51. Find the median height. Solution. To calculate the median height, we need to find the class intervals and their corresponding frequencies. The given distribution being of the less than type, 140, 145, 150 up to 165, giving the upper limits of the corresponding class intervals. So, the classes should be below 140, 140 to 145, 145 to 150, up to 160 to 165. Observe that from the given distribution, we find that there are 4 girls with height less than 140. That is, the frequency of class interval below 140 is 4. Now there are 11 girls with heights less than 145 and 4 girls with height less than 140. Therefore, the number of girls with height in the interval 140 to 145 is 11 minus 4 equal to 7. Similarly, the frequency of 145 minus 150 is 29 minus 11 equal to 18. For 150 to 155, it is 40 minus 29 equal to 11, and so on. So, our frequency distribution table with the given cumulative frequency becomes class intervals, frequency, cumulative frequency. Below 140, 4, 4. 140 to 145, 7, 11. 145 to 150, 18, 29. 150 to 155, 11, 40. 155 to 160, 6, 46. 160 to 165, 5, 51. Now, n is equal to 51, so n by 2 is equal to 51 upon 2 equal to 25.5. This observation lies in the class 145 to 150. Then L, the lower limit, is equal to 145. CF, the cumulative frequency of the class preceding 145 to 150, is equal to 11. F, the frequency of the median class 145 to 150, is equal to 18. H, the class size, is equal to 5. Using the formula, median is equal to L plus n by 2 minus CF upon F into H equal to 145 plus 72.5 upon 18 equal to 149.03. So the median height of the girls is 149.03 centimeters. The median of the following data is 525. Find the values of x and y if the total frequency is 100. Class interval frequency 0 to 100 2, 100 to 200 5, 200 to 300 x, 300 to 400 12, 400 to 500 17, 500 to 600 20, 600 to 700 y, 700 to 800 9, 800 to 900 7, 900 to 1000 4. Solution: class intervals, frequency, cumulative frequency. 0 to 100 2 2, 100 to 200 5 7, 200 to 300 x 7 plus x, 300 to 400 12, 19 plus x, 400 to 500 17, 36 plus x, 500 to 600 20, 56 plus x, 600 to 700 y, 56 plus x plus y, 700 to 800 9, 65 plus x plus y, 800 to 900 7, 72 plus x plus y, 900 to 1000 4, 76 plus x plus y. It is given that n is equal to 100. So 76 plus x plus y is equal to 100. That is, x plus y is equal to 24. The median is 525, which lies in the class 500 to 600. So L is equal to 500, F is equal to 20, CF is equal to 36 plus x, H is equal to 100. Using the formula, median is equal to L plus n by 2 minus CF upon F into H. 525 is equal to 500 plus 50 minus 36 minus x upon 20 into 100. That is, 525 minus 500 is equal to 14 minus x into 5. That is, 25 is equal to 70 minus 5x. That is, 5x is equal to 70 minus 25 equal to 45. So, x is equal to 9. Therefore, from 1, we get 9 plus y is equal to 24. That is, y is equal to 15. The mean is the most frequently used measure of central tendency because it takes into account all the observations and lies between the extremes. Mean enables us to compare two or more distributions. Mean is affected by extreme values in the data effect. Example, the mean of classes having frequencies more or less the same is a good representative of the data. But if one class has frequency, say 2, and the 5 others have frequency 20, 25, 20, 21, 18, then the mean will certainly not reflect the way the data behaves. So in such cases, the mean is not a good representative of the data. Median is more appropriate in problems where individual observations are not important and we wish to find out a typical observation. Example, finding the typical productivity rate of workers, average wage in a country, etc. These are situations where extreme values may be there. So, rather than the mean, we take the median as a better measure of central tendency. Mode is the best choice in situations which require establishing the most frequent value or most popular item. Example, to find the most popular TV program being watched, the consumer item in greatest demand, the color of the vehicle used by most of the people, etc. Note 1. There is an empirical relationship between the three measures of central tendency. 3 median is equal to mode plus 2 mean. 2. The median of group data with unequal class sizes can also be calculated.
Measures of central tendency: mean, median, mode. Direct method, step deviation or shift of origin and scale method. Assumed mean or shift of origin method. Mean of grouped frequency distribution. Direct method. The steps to calculate mean by direct method is as follows. Prepare a table containing 4 columns. In column 1, write given class intervals, and in column 2, write the corresponding class marks x1s. In column 3, write frequencies FIS of the given class intervals, and in column 4, write the product FIXI and find the sum. Calculate mean, average, arithmetic mean by using the formula. Average arithmetic mean is equal to summation FIXI upon summation FI, where XI class marks of xth class interval, FI frequency of ith class interval. Assumed mean method or shift of origin method. Sometimes the value of FIXI obtained by direct method are very large. In that case, we use assumed mean or shift of origin method. The steps to calculate mean are as follows. Prepare a table containing 5 columns. In column 1, write given class intervals, and in column 2, write the corresponding class marks, xi. In column 3, write the value of t, where di is equal to xi minus a, where a is assumed mean. In column 4, write frequencies fi of the given class intervals, and in column 5, write the product fi di. Find the sum for both the columns. Find mean of di by using the formula. Calculate mean by using the relation. Note, usually A is taken as class mark of middle class. Step deviation method to shift of origin and scale method. The calculations for giving values of mean were made simple by shift or origin or assumed mean method. We can make the calculations more easy by using step deviation method of shift of origin and scale method. The steps to find the mean are as follows. Draw a table containing 6 columns. In column 1, write the given class intervals, and in column 2, write the corresponding class marks XIS. In column 3, write the values of DIS, where di is equal to xi minus a. In column 4, write the values of uis, where ui is equal to xi minus a upon h is equal to di upon h, where h class width. In column 5, write frequencies fi S of the given class intervals, find the sum. Find mean of UIS by using the formula. Find mean of X by using the relation. Note, while finding mean, use step deviation method as the calculation becomes easy even though columns required are more. If the class's intervals are inclusive, that is, not continuous class, the first always make the class continuous for mean, median, mode, though it is not required for mean except when you are using step deviation method. Median for grouped frequency distribution. Median is that value of data which divides the set of data into two equal parts. Following are steps in calculation of median for grouped frequency distribution. Prepare a table containing 3 columns. Write given class intervals in column 1 and their respective frequencies in column 2. Write cumulative frequencies less than type in column 3. Find total frequency n is equal to summation f1, calculate n upon 2. Find cumulative frequency less than type which is just greater than or equal to n upon 2. The corresponding class is median class. Calculate the value of median by using the formula median is equal to L plus n upon 2 CF, HF, where L, lower limit of median class, n, total frequency, CF, cumulative frequency less than type of the class preceding median class, H, width of median class, F, frequency of median class. Note, if class intervals are of inclusive type, make them exclusive type by finding class boundaries. In this case, L is equal to lower boundary of median class. Mode for grouped frequency distribution. Mode is the observation of data having maximum frequency, where we have studied how to calculate mode for ungrouped frequency in Standard 9. Now let us study how to calculate mode for grouped frequency. Steps. Find the maximum frequency denoted by FM. Determine the class corresponding to FM. This class is called as Modal Class. Calculate the value of mode by using the formula. Mode is equal to L plus Fm minus F1 upon 2Fm minus F1 minus F2, whole multiplied by H, where L, lower limit of modal class, Fm, maximum frequency, F1, frequency of pre-modal class, F2, frequency of pre-modal class, H, width of modal class. Note, in case of grouped frequency distribution, it may happen that 2 or more classes may have same maximum frequency. We shall not discuss calculation for mode in such situation. Interrelation between measures of central tendency. We have studied 3 measures of central tendency: mean, median, and mode. There exists empirical relationship among these 3 measures of central tendency. This relationship was stated by Professor Carl Pearson on the basis of his vast experience. The relationship is mean minus mode is equal to 3 mean minus median. It cannot be proved theoretically, but is observed to be valid for number of data sets after actual calculations. We know that in some cases mode cannot be determined. In these cases, we can use the above relation to determine the value of mode approximately. If the values of 2 measures of central tendency are known, we can use the above relationship to find the approximate value of remaining measure of the central tendency. Solved examples. Example 1. For a certain frequency distribution, values of mean and median are 62.6 and 62.5 respectively. Find the value of mode. Solution. We know that mean minus mode is equal to 3 mean minus median. 62.6 minus mode is equal to 3 bracket 62.6 minus 62.5. 62.6 minus mode is equal to 3 bracket 0.1. 62.6 minus mode is equal to 0.3. Mode is equal to 62.3.